Graphically solving a system of linear equations. I have left up the information that we used from classifying a system in order, because we're going to be referring to it here once we've graphed our lines. The first thing we've got to do is figure out what our points are. Now, of course, Alex gives you two equations. That's all it gives you. So remember, in order to graph, you need to be making a t-chart. Okay, again, I use the points for the numbers -1, 0, and 1 for this example. And to make life easier to solve for that y, I'm going to go ahead and move this -2x to the other side. So I'm going to add 2x here, add 2x here. And of course, if it was a positive, you'd subtract. So now I've made my equation into slope-intercept form, just because it's easier to find our points this way. And so now that you've done that, we're going to substitute that -1 into the equation. So y equals 2 times -1 plus 4. 2 times -1 is -2 plus 4. So y equals 2. So that's our first point. Next, we're going to substitute the 0 in. So 2 times 0 plus 4. 2 times 0, of course, is 0. So we've got y equals 4. And we're going to substitute our next one in. So 2 times just 1, sorry. Just a positive 1, plus 4. So 2 times 1 is 2, plus 4 is 6. Okay, I'm going through this kind of quickly, because this should be a review at this point for you. Okay, this equation has a fraction in it, and so in order to make life a little bit easier for us, if you have not picked up that calculator to where you can enter your fractions in, what you can do is use whatever number the denominator is. So in this case, it's a 2, so we could use -2, 0, and 2. Okay, let me kind of put a line straight through there. Okay, so now we've got y equals -1/2 times -2. And of course, you can still do this regardless whether you've picked up that calculator or not. You can still type in the fraction and then parentheses your -2. Okay, and if you don't have it, what happens is, of course, these 2's, they end up canceling, and a negative times a negative is a +1. We're going to bring down our -1. So y equals, in this case, 0. Okay. The next part, we're going to put y equals -1/2 times 0, which of course is 0, so we can just mark that out. So y equals -1. I don't know why it glitches like that. Okay, and the next one we've got is y equals -1/2 times 2 minus 1. Again, if you're not using that calculator, these 2's end up canceling each other, leaving us just a -1 minus 1. So y equals -2. Okay, so we've got both sets of points for our graph. So what I'm going to do is I'm going to kind of bring Alex over into the screen, and we're going to graph one line at a time, remembering that we want to make Alex do most of the work. Okay, so this way there's no Alex marked it wrong and I don't understand, my graphs look right. Make Alex do the work, and that way there's no doubt. So we're going to press our exact point thing, and we're going to type in -1, 2 for our first point. Let me spread this out. Maybe it'll look better. So here's our dot. I'm going to do the next one is 0, 4. Okay, make sure that you're actually clicking in those boxes or you're using the right arrow key. And 1, 6. Okay, notice we've got our 3 dots. So before we even look at the second line, we're going to graph this one first. So notice it kind of snapped into place, and we can go up and mark our other one. So now we've got one line. I'm going to kind of move this over here so that way we can look at our second one. Again, make Alex do the work. So -2, right arrow key, 0. And then we're going to do 0. Oh, got to click on it. 0, right arrow key, -1. And 2, right arrow key. Oh, I didn't click on it again. -2. Plot. Notice we've got our 3 dots right here. So we're going to click on our line, place our first point and our last point. Now, as you can see, this is where our examples come into play, is we need to look at these and say, okay, well, it's definitely not an infinite mini solution. They do cross at one point. So we're going to have one solution. So you're going to select your ordered pair here. And then you're going to look at your graph, and here at the intersection, the point that they meet, in this example, is -2. And you can either right arrow key or click on the box, and 0. And of course, you'll click check solution. Now, of course, if these were lines that stacked on top of each other, you do need to draw both of them. And then you would select which solution. So if they stacked on top of each other, it would be infinite many. If they didn't touch at all, it would be no solution.